This video is about function notation. So this is another kind of review video about functions. In case we forgot, a function is when an equation satisfies the definition of a function. Basically, every input has one output. The output is the f of x, and we just use f for function, but it really could be any letter with the x in parentheses. And then we have the equation part. We'll do composite and compound functions later, so don't worry about that right now. The proper way to read the function on the screen would be f of x equals 5 times x plus 3, or f of x equals 5x plus 3. So basically, you can take any y equals that satisfies the definition of a function and turn that into function notation. So our first example here, y equals 5x plus 3, we've got x and y. So in the parentheses, our solution for this is going to be x, comma, and then y. So that would be the 5x plus 3. If we were to rewrite this in function notation, our solutions, instead of being x and y, would be x and f of x. It's the same kind of thing. So our x value would still be x, and our f of x is 5x plus 3. It's just a convenient way of writing functions. And while it might not seem convenient for this, it makes things later on more convenient. So in essence, y is equal to f of x, assuming it's a function. And this is handy for a couple reasons. The one that's kind of right now is whatever that x value is your input, is what you're going to plug in for x to solve your equation. So in this case, f of 1 would be 5 times 1 plus 3. We can also take a look at functions like this and evaluate our function. So let's do evaluate f of 0. F of 0 would be the y value where x is 0. That looks like f of 10. That's ugly. That's better. So f of 0. So here's x equals 0. Our function value is 3. Let's take a look at f of 1/2. Where the x value is 1/2, the y value is 0. And lastly, f of -2. Where our x value is -2, our y value is, looks to be 4. It's literally that hard. This works for equations as well, so let's do 0, 1/2, and -2 for a couple different examples. Our first example will be f of x equals 8 plus 4x. So as you see, all I'm doing is taking the 0 and plugging it in where x is, and then solving. Same thing for 1/2. I plugged it in here. 4 times 1/2, order of operations, 2, and then 2 plus 8, 10. It's not so hard. Same thing down here. 4 times -2 is -8. 8 plus -8 is 0. Works the same way, whether or not, you've got squares or other stuff going on. All we do is plug in the value where x goes and then solve. Whether that be on pencil and paper or with a calculator, you plug it in and solve. Plug and chug, as they say. Now, x could be other stuff, so that x value can represent even another equation. This one down here is h of x. H of x equals 5x plus 3. And my instructions are solve for h of x minus 2, h of 9x, and h of x squared. So what I'm going to do is just replace where the x is in the equation with the stuff in the parentheses. So this 5x, I'm replacing the x with x minus 2. For the 9x, I'm replacing the x with 9x. And for down here, I'm replacing the x with the x squared. So you can replace it with stuff, not just one thing necessarily. Down here with the t, you can see that I replaced the t in both places it appears in the equation. So I've got 2t squared minus 7t. For t is t plus 1. So I replaced this t with t plus 1. And I replaced this t with t plus 1. For t equals 4, replace it with t. For t equals t squared, I replace both t's with t squared. So you just replace whatever letter was originally in the parentheses with whatever the problem says you should replace it with. One more important thing about functions, anything on the x-axis, the horizontal, is independent, and anything on the y-axis is dependent. And the reason is because the y value depends on what the x value is. So let's go ahead and look at that in terms of a word problem here. A carnival charges a $5 entry fee and $2 per ride. Write a function to represent the total cost after taking a certain number of rides. So the independent, the thing that doesn't depend on anything, is the number of rides I take. Let's go ahead and write that in there, number of rides. The dependent would be the cost, because the cost depends on the number of rides. So total cost. And I say total cost because we have an entry fee cost and a ride cost. Our equation, the cost, depending on the rides, is equal to the $5 entry fee plus $2 per ride. And if we want to know how much 12 rides cost, we just plug it in. So 12 times 2, 24, and then plus 5. That means 12 rides is going to cost us $29. And while this does seem silly in this particular case, this is actually something that if you run a business, you do on a regular basis. All right, last example. A local photo shop will develop and print the photos from a disposable camera for 25 cents per print. Write a function to represent the cost of photo processing. Okay? The independent variable here would be the number of photos, because it doesn't depend on anything. So number of photos. And our dependent, again, here is going to be our cost. Cost is generally a dependent variable. Okay, so the cost of pictures is equal to 0.25 cents per picture. Pretty easy. So how many photos could I develop? Well, all we have to do is take, for $5.25. So we're going to replace our total cost with $5.25. That's going to equal to 25 cents per print. I think this is pretty obvious what you should do. Just divide. So I'm going to divide by 25 cents. $5.25 divided by 25 cents is 21. So you can do 21 photos. I want to be super clear here that when you answer a word problem like that, notice how I put $29 and 21 photos. You need to identify what it is that you're solving for. All right, that's it.